Hello dear learner. Welcome to this session on electric iron and immersion rod of the third module on electrical thermal appliances of online course on domestic equipment maintenance. I am Dr. Bikramjit Goswami, Associate Professor in the Department of Electrical and Electronics Engineering at Assam Don Bosco University, Guwahati. This session will introduce the working internal parts, troubleshooting and repairing of electric iron and immersion rod to you. First, let us start with the discussion on electric iron. The electric iron is a widely used household appliance that plays a crucial role in fabric care and maintenance. Let us understand the construction of an electric iron first. Construction of an electric iron. An electric iron comprises of the following key components: heating element, thermostat, and a sole plate. Heating element. The heating element is usually made of a high resistance alloy such as nichrome wire, which is wound into a coil. This element is responsible for generating heat when an electric current passes through it. Thermostat. The thermostat is a temperature control device that regulates the iron's temperature. It consists of a bimetallic strip that expands or contracts based on the iron's temperature. This strip is connected to a switch that turns the heating element on or off to maintain the desired temperature. Sole plate. Sole plate is a flat, smooth surface of the iron that comes into direct contact with fabrics. It is typically made of materials like aluminum or stainless steel with a non-stick coating to ensure smooth gliding and prevent fabric damage. Dear learner, having learned about the construction of an electric iron, let us now discuss the working principle of it. The working principle of an electric iron involves the following steps. Power supply. When the iron is plugged into an electrical outlet, the power supply delivers electricity to the iron's internal circuitry. Heating element activation. The electric current flows through the heating element, which offers resistance. This resistance converts electrical energy into heat, causing the heating element to reach a high temperature. Temperature control. The thermostat monitors the temperature of the heating element and adjusts the power supply accordingly. If the temperature drops below the desired level, the thermostat activates the heating element to increase the heat. When the temperature exceeds the set level, the thermostat interrupts the power supply to maintain a consistent temperature. Dear learner, let us now go through some important features of an electric iron. Modern electric irons often include several additional features for enhanced usability and convenience. Some common features include temperature settings. Electric irons offer adjustable temperature settings to accommodate different types of fabrics. Delicate fabrics require lower temperatures, while tougher fabrics may need higher temperatures. Auto shutoff. To enhance safety and energy efficiency, some irons are equipped with an auto shutoff feature. This feature automatically turns off the iron when it remains idle for a certain period. Cord length and swivel. Electric irons feature a power cord with an appropriate length for easy maneuverability. A swivel cord prevents tangling during ironing. Dear learner, after going through the construction, working principle, and features of an electric iron, let us now attempt some questions to test our knowledge gained from the discussion so far. Well, dear learners, after going through the questions, now we discuss the different components of the internal circuit of an electric iron. The internal circuit of an electric iron consists of the following key components. Power input. The power input component receives the electrical supply from an external source, typically a wall outlet. It may include a power cord with appropriate connectors for connecting to the main circuitry. On and off switch. The on-off switch is responsible for controlling the power flow to the internal circuit. When turned on, it allows the current to pass through and activate the iron's heating element. Heating element. The heating element is a crucial component responsible for converting electrical energy into heat. It typically is made of a high resistance alloy such as nichrome wire, which offers substantial resistance to generate heat when an electric current passes through it. The heating element is connected in series with the power supply and controlled by the thermostat. Temperature control system. The temperature control system ensures that the iron operates at the desired temperature for different fabrics. It typically comprises the following elements. Number 1, thermostat. The thermostat is a temperature sensing device that detects the temperature of the iron's heating element. It is usually a bimetallic strip that expands or contracts based on temperature changes. The thermostat is connected to the power supply and controls the heating element's activation and deactivation to maintain a consistent temperature. Number 2, temperature dial. The temperature dial allows users to adjust the desired temperature settings. It is connected to the thermostat and alters the resistance or current flow according to achieve the desired temperature. Safety mechanisms. The electric irons often incorporate safety features to protect against overheating, electrical malfunctions, and accidents. Common safety mechanisms include thermal fuse. The thermal fuse is a temperature-sensitive component that disconnects the power supply to the heating element if the iron reaches an unsafe temperature. It acts as a fail-safe measure to prevent fire hazards. Overheat protection. Overheat protection circuits monitor the iron's temperature and activate when it exceeds a specific threshold. These circuits can trigger an alarm, cut off power, or activate the thermal fuse to prevent further temperature rise. Repairing of electric irons. Electric irons are commonly used household appliances that may require occasional repairs due to wear and tear, component failure, or electrical issues. This part of the session gives an overview of the repair process of electric irons, including troubleshooting common problems, disassembly, component replacement, and safety considerations. Before attempting any repairs, it is essential to diagnose and identify the specific problem with the electric iron. Ensure the iron is unplugged and has had sufficient time to cool down before starting any repairs. Common issues encountered with electric irons are no power. If the iron does not turn on or show any signs of power, check the power cord, plug, and outlet for any damage or loose connections. Test the power supply using a multimeter to ensure it is functioning correctly. No heat or insufficient heat. If the iron is not heating up adequately or not at all heating, the heating element or thermostat may be faulty. Test the heating element with a multimeter to check for continuity. Inspect the thermostat for any signs of damage or malfunction. Auto shut-off issues. If the iron has an auto shut-off feature and it is not working correctly, inspect the circuitry associated with the auto shut-off mechanism. Check for loose connections, faulty components, or incorrect settings. Accessing internal components. Depending on the iron's design, remove any visible screws or clips that secure the housing. Carefully separate the iron's housing to get access to the internal circuitry and components. Component inspection. Inspect the heating element, thermostat, control valves, wiring, and other relevant components for damage, wear, or loose connections. Use a multimeter to test components for continuity, proper resistance values, and correct functioning. Component replacement. Replace faulty components with suitable replacements. Ensure the new components are compatible with the iron specifications and follow proper installation procedures. Take note of the original components' wiring connections and replicate them during replacement. Dear learner, repairing an electric iron can help extend its lifespan and restore its functionality. By troubleshooting common problems, disassembling the appliance, and replacing faulty components, users can address these issues related to power supply, heating, water leakage, or auto shut-off mechanisms. However, it is crucial to prioritize safety throughout the repair process, follow proper procedures, and seek professional assistance when needed. Regular maintenance and timely repairs can contribute to the efficient and safe operation of electric irons. Now, since we have come to know about the different internal components and their repairing options, we will move towards a self-test with the following questions. Dear learner, thus we come to the concluding section of this session on electric iron. Electric irons are indispensable appliances for maintaining wrinkle-free fabrics. Their construction, working principle, and features have evolved over time to provide efficient and safe ironing experiences. By understanding the construction, working principles, and safety considerations associated with electric irons, users can make informed decisions and ensure safe usage while prolonging the appliance's lifespan. The internal circuit of an electric iron is a complex system that integrates various components to ensure efficient heating, temperature control, and safety mechanisms. Understanding the internal circuitry helps users comprehend the iron's functionality, use it effectively for fabric care, and appreciate the safety features designed to prevent accidents or overheating. Manufacturers continue to enhance internal circuit designs to improve energy efficiency, user experience, and overall safety in electric irons. Alright, dear learner, now that we have completed our discussion on electric iron, we will move towards another very common household electric device that is used for heating water. It is an immersion rod. The immersion rod is a commonly used electrical appliance for heating water in households, commercial establishments, and industry settings. This session will give you an overview of the immersion rod, its construction, working principle, advantages, limitations, and safety considerations. Construction of an immersion rod. An immersion rod consists of the following key components. Heating element. The heating element is typically made of a high resistance alloy such as nichrome or stainless steel. It is designed to withstand high temperatures and effectively convert electrical energy into heat. Insulation. The heating element is surrounded by an insulating material such as mica or ceramic to prevent direct contact with water and ensure electrical safety. Handle and power cord. The immersion rod is equipped with a handle for easy handling and a power cord for electrical connection to a power source. Working principle of an immersion rod. The immersion rod utilizes the principle of electrical resistance heating. When the power supply is connected, an electric current flows through the heating element, which has a high resistance. This current causes the heating element to heat up, and the heat is transferred to the surrounding water by conduction. The water absorbs the heat and gradually increases in temperature. Advantages of an immersion rod. The immersion rod offers several advantages. Cost effectiveness. Immersion rods are relatively inexpensive compared to other water heating options such as geysers or solar water heaters. Portability. Due to their compact size and lightweight construction, immersion rods are highly portable and can be easily carried and used in different locations. Quick heating. Immersion rods heat water rapidly, providing hot water on demand without the need for preheating or waiting. Versatility. Immersion rods can be used in various water storage containers, including buckets, bathtubs, and water tanks. Energy efficiency. Since immersion rods heat water directly, they eliminate heat losses associated with long pipe runs, resulting in improved energy efficiency. Limitations of an immersion rod. Despite their advantages, immersion rods have some limitations. Limited capacity. Immersion rods are primarily suitable for heating small to medium quantities of water. Heating large volumes of water may take longer or may not be feasible. Safety risks. Improper handling or operation of immersion rods can pose electrical and fire hazards. It is essential to follow safety guidelines and precautions to prevent accidents. Dependency on electricity. Immersion rods rely on a stable electricity supply. Power outages or voltage fluctuations can affect their operation. Lack of temperature control. Most immersion rods do not have built-in temperature controls. Users must manually monitor the water temperature to prevent overheating. Dear learner, having discussed all these topics on immersion rod, let us do some self-check about the knowledge gained by attempting the following questions. After attempting the questions, now let us learn about few more aspects related to an immersion rod. Safety considerations for an immersion rod. To ensure safe and efficient operation of immersion rods, the following safety considerations should be observed. Proper electrical connections. The immersion rod must be connected to a properly grounded power outlet using the provided power cord. Loose or damaged connections should be avoided. Adequate water level. The immersion rod should be fully immersed in water to prevent overheating and damage to the heating element. Unplug after use. After the water has reached the desired temperature, the immersion rod should be immediately unplugged from the power source to avoid unnecessary energy consumption and potential accidents. Avoid flammable substances. The immersion rod should not be used near flammable materials or substances such as gasoline or solvents to prevent fire hazards. Regular inspection. Periodic inspection of the immersion rod, power cord, and insulation for any signs of damage or wear is recommended. Damaged components should be repaired or replaced promptly. Repairing of immersion rod. Over time, immersion rods may require repairs due to issues such as faulty wiring, heating element failure, or electrical malfunctions. In this part of the session, we will have an overview of the repair process for immersion rods, including troubleshooting common problems, disassembly, and component replacement. Troubleshooting common problems. Before proceeding with repairs, it is important to diagnose the specific problem with the immersion rod. Common issues encountered with immersion rods include no power or heating. If the immersion rod does not heat up or show any signs of power, check the power cord, plug and outlet for any damage or loose connections. Test the power supply using a multimeter to ensure it is functioning correctly. Uneven heating or overheating. If the immersion rod heats up unevenly or excessively, there may be issues with the heating element or the thermostat. Test the heating element with a multimeter to check for continuity and proper resistance values. Inspect the thermostat for any signs of damage or malfunction. Water leakage. If the immersion rod is leaking water, inspect the sealing gasket, O-rings, or any other components responsible for water tightness. Replace any damaged or worn out parts to prevent water leakage. Overheating or burning smell. If the immersion rod emits a burning smell or becomes excessively hot during the operation, it may indicate an electrical issue. Inspecting the wiring, connections, and insulation for any signs of damage or improper installation. Disassembly and component replacement. Repairing an immersion rod may involve disassembling the appliance to access and replace faulty components. Follow these general steps. Safety precautions. Ensure the immersion rod is unplugged and disconnected from the power supply. Allow it to cool down completely before starting any repairs. Wear appropriate protective gear such as gloves and safety glasses to prevent injuries. Accessing internal components. Depending on the immersion rod's design, remove any visible screws or clips that secure the housing. Carefully separate the housing to gain access to the internal wiring, heating element, thermostat, and other components. Component inspection. Inspect the wiring connections, heating element, thermostat, and other components for any signs of damage, loose connections, or wear. Use a multimeter to test the heating element for continuity and proper resistance values. Check the thermostat for correct functioning. Component replacement. Replace faulty or damaged components with suitable replacements. Ensure the new components are compatible with the immersion rod's specifications. Follow proper installation procedures, ensuring all wiring connections are secure and correctly positioned. Repairing an immersion rod can help extend its lifespan and restore its functionality for efficient water heating. By troubleshooting common problems, disassembling the appliance, and replacing faulty components, users can address issues related to power supply, heating element, thermostat, or water leakage. However, it is crucial to prioritize safety throughout the repair process, follow proper procedures, and seek professional assistance when needed. Regular maintenance and timely repairs can contribute to the safe and efficient operation of immersion rods. Okay, dear learner, now since we have almost come to the concluding section of the session, we can now attempt a few questions to test our learning. Alright, dear learner, after attempting these questions, now we come to the end of the session. Let us summarize what we have discussed about an immersion rod. The immersion rod is a convenient and cost-effective appliance for heating water. Its portable design, quick heating capabilities, and versatility make it a popular choice for various applications. However, users must exercise caution and adhere to safety guidelines to ensure the safe and efficient operation of immersion rods. Regular maintenance and inspection are essential to identify and address any potential risks or issues. The heating element and the power supply can be checked for their healthiness in case any abnormality in operation of the immersion rod is observed. So, we come to the end of our discussion on electric iron and immersion rod. Hope you have learned few basic points regarding these two very common electrical appliances. Do not forget to post your questions and queries. Thank you.